Good afternoon, everyone. We are Group 2 from Tutorial 3. Today we are having a presentation of extended use of BIM in construction, the Internet of Things. The following presentation will be divided into 6 parts, including an introduction, applications, benefits, challenges, suggestions, and also the conclusions. Let's start with the introduction. The Internet of Things refers to a network enabling the connection, collection, and exchange of data from electronic devices. It is the combination of devices and automated systems to integrate and analyze information, and it gives a solution to the people for the completion of tasks. At the same time, the BIM is a 3D model process, including the generation and management of physical and functional features of a project in terms of digital ways, and it covers forming aspects, that is, the design stage, construction, operations, and maintenance. Nowadays, there are increasing number of applications of IoT in building purposes, since the IoT-capable devices can collect a huge amount of real-time data from the buildings. The construction sector is likely to integrate the IoT into BIM for improving the building performance and help in obtaining and transmitting information, which will be further analyzed through a comprehensive plan for the management. In today's Hong Kong, the IoT technology is being adopted to enhance the construction process. For example, major bridge and tunnel projects in Hong Kong have used the IoT sensors to achieve the real-time monitoring. In the real estate market, these sensors also add value to the smart buildings. Lastly, the Hong Kong government has promoted the integration of IoT into BIM to pushing the city forward as a smart city.
I'm going to introduce 3 applications with the integration of BIM and IoT. The first application is monitoring progress in construction stage. BIM has integrated into development of surface to visualize construction progress, while IoT enables the management and workers to report and check the construction progress in shared database. The assembly of precast components will be used as an example to illustrate how the system can be used in reality. Workers and foremen, managers, and manufacturers and logistic companies can be collaborated closely. They can distribute information, monitor real-time status of precast elements, and make any modification through order database effectively. Besides, the real-time status of precast elements will be recorded and shown on map. The cumulative quantity of precast components erected would be plotted onto a graph compared to the scheduled progress. In order to identify any delay in site construction, the progress can be further applied with real-time visualization. Secondly, it comes to tool and safety management on construction sites. The wireless technology allows both workers and electrical devices to connect to the Internet through cloud and to each other. This enables the workers to send instructions to the tools, as well as interacting and collaborating with them. Particularly for underground construction or in confined spaces, wireless sensor nodes can check about temperature, humidity, hazardous gas location and level. Safety status in construction sites can be monitored. The site BIM model will display all environmental conditions and indicate safety status. These can be used in regular site safety management. The third application is monitoring and adjusting indoor environment. It demonstrated the application in collecting live and historical sensor data to database. Several environmental conditions in rooms, including temperature, gas levels, sound levels, etc., can be recorded and the information will be transmitted and stored in real time over the cloud. The smart devices could make corresponding adjustment to the environmental conditions by different periods of time in the day in order to achieve occupants' comfortability.
Then here comes to the benefits part. We will focus on 2 stages, and let's start with the construction stage. Firstly, it can enhance the information transmission between the workers and the logistics, and the accurate scheduled order for the prefabrication can solve the disordered material placement, and the time labor force can furthermore be saved from the rehandling process. Secondly, the integration can help improving the equipment monitoring and safety management. especially in the special security risk engineering. As safety is the most critical factor for working on site, the IoT devices can check the underground condition, which may enhance the rescue efficiency and lower the possibility of delay in rescue. And now, let's move on to the operation and maintenance phases. IoT devices collect the real-time data and import to the BIM system. A clear picture can be made about the energy use. Then, according to the real-time data and the historical record, temperature, humidity, and even the lighting system can automatically be adjusted. Also, a better available performance can be achieved. By combining the collected data, room booking system, and the BIM system, the available rooms can easily be traced and a better space management can be achieved with the integration. As we all know, advantages and disadvantages are always occurred in pairs. Therefore, let's take a look at the challenges and the problems from the integration. And the first one is the universality. The integration of BIM and IoT may change people's working habits and the traditional lifestyle, but it's not that easy to overcome the changes, and years are needed for the complete adaptation. Next, due to the real-time data collection and the visualization, a higher internal capacity is required for the operating computers and the portable gadgets. Otherwise, overloaded problems may occur while operation. And for the practicality, some people claim that the integration works are only conducted in the laboratories and it is not practicable in real life. To mitigate the misunderstandings, education, promotion, and more public applications can be the ways letting technology assimilate into people's daily life. Finally comes to the last part, the privacy. The data collection thus helps enhancing the construction management and the energy efficiency. However, at the same time, privacy will become publicity as the future database. Then what is more important? Privacy or technology? This will be one of the challenges for the future technologies integration.
I will talk about the part of the suggestion, which means how the technology contribute to the better use of the BIM. There's a four example of the technology that can contribute to the better use of BIM. First of all is the computer resolution, the VR, photogrammetry, and the robotics construction. First of all, the computer. The evolution of the computer improvement in the CPU, the faster speed, the RAM, which people can do more software in the same time. The graphic card, people can do a 3D graphic more easily. It can reduce the speed of the whole process, such as drawing, design the building or the project. The 3D graphics easily to generate a 3D model for the site management, and the software efficiency, such as the CAD, we can do the crash detection very quickly, and the automation, the robot and the machine. And the second one is the VR. We can use the VR to provide a first or third person point of view to work through the construction project. It's good for design process and finds the mistake, and the designer can have a real-time image on the buildings. We can reduce the time of the correction and reduce the time of the creation, reduce the cost and increase the efficiency. And photogrammetry, which is the alternative of the laser scanner with a lower cost and easily to obtain. 3D image must be used in the construction by some software such as CAD or Vivid. Laser scanner is expensive and requires specialized. So photogrammetry is very quickly to use and very quickly to learn and obtain in the construction environment, which is have a lower cost. And the digital camera evolution also helps a lot to do easily 3D graphic. And the robotics construction is a serious impact to the construction industry. Improve the robotic technology can change the working way of the construction, which is the labor intensive. And before the robot needs to complex code by the specialist, nowadays is very easy by lots of preset button. For example, the printing robot, the 3D printing. The first printing bridge in the Netherlands have been built out in the past few years, and the robot can layering the brick and doing mastery work, and the demolishing robot can break down the old building in a safer and a cheaper way. Internet of Things in the BIM is really helps a lot in the construction industry. Manage better and construct more accurately. And we use the IoT, kick away the OT. Thank you. This is the end of our presentation.